Hello, my wonderful peeps. Today's podcast, Algebra Nation, Workbook, page 80. We will do all of page 80, problems 5 and 6.
Alright, let's look at this problem about amusement parks. The scatter plot below shows the trend of the relationship between the number of amusement park tickets sold and the outside temperature. Use the scatter plot for all parts of this question. Alright, so it's telling us something about amusement park ticket sales. So that's what this scatter plot is telling us. It's showing us the temperature on the x-axis and the tickets sold on the y-axis. Alright, let's see what we can learn from looking at this graph. A. What is the approximate number of amusement park tickets sold when the temperature reaches 90 degrees? So let's take a look at our graph. It's 90 degrees. I know I'm looking at this x-axis. 90 degrees. Let's look up here. Oh, right here. When it's 90 degrees, it is approximately about, let's say, so when it's 90 degrees, because that's my x-axis, right? It's about, I would say, 60 tickets sold. Now, if you could guesstimate, you'll probably look at this and say, well, it could be 58, probably 58, 57, somewhere in there. But I'm just going around, it's about 60 tickets sold. All right, so 60 tickets sold. What is the approximate number of amusement park tickets sold when the temperature reaches 20 degrees? So 20 degrees is right here. And I'm going to say it's about approximately 20 tickets sold. So, about. So when it's 20 degrees, that's the x, remember, then we know that it's about 20 tickets sold. Because that's really cold, actually. Who's going to the amusement park? Who are those 20 brave people who are going to the amusement park? I don't know. It's kind of crazy, but hey. All right. So our last part, C. Oops, let me show you so you can see. Using these two approximated, that means about, points, use the slope formula to find the approximate slope of the line of best fit. In your own words, describe what this slope represents. All right. So let's find the slope. I have 2 points. Remember, I have 2 relationships. It's showing that when it's 90 degrees out, they sold 60 tickets. When it's 20 degrees out, they only sold 20 tickets. And I don't know who those 20 people are, but they're very brave. All right, so let's check this out. I have 2 points. So my slope formula, remember, is slope equals y2 minus y1 over x2 minus x1. Okay, so y2, let's say this is y2, x1. Excuse me, this is x2, y2. This is x1, y1. y2 is 20 minus 60 over 20 minus 90. Okay. 20 minus 60 is negative 40. 20 minus 90 is negative 70. Let's see if I can reduce that. All right? That's negative 40 divided by negative 70. Negative 10 goes into both the numerator and the denominator. It goes into both negative 40 and negative 70 evenly, right? So negative 40 divided by negative 10 is 4. Negative 70 divided by negative 10 is 7. So our slope is 4 over 7. All right, so what does that mean? All right, well, first thing we see, it's a positive slope, which is definitely true. You can see the line is going up. The scatter plot is going up. That means that the more the temperature increases, the hotter it gets, the more tickets are going to be sold, right? All right. It also means for the slope, remember, slope is rise over rise, or y over x, the change in y over the change in x. So what that means is for every all that means is for every 7-degree increase in temperature, 4 more tickets are sold. That's the relationship. So for every 7 degree in temperature, if I increase by 7 degrees, I must sell 4 more tickets. Now this is approximate. The most important thing for you to remember is that if it's a positive slope, it means there's a positive correlation, right? So here, there's definitely a positive slope that I saw. So it means as the temperature increases, ticket sales increase. If temperature decreases, if it goes down, then ticket sales will also go down, right? If it's really cold, no one wants to go to the park. That's all it's saying, all right? If you have any questions about this problem or any other problem, go ask your questions on the algebra wall. See you next time.
Ready for a brain break? You got to be like this guy when it comes time for you to take the EOC.
Well, this is another sports interesting thing going on. We all know how difficult it is to catch that foul ball at a baseball game, right? Well, one guy walked right into his, literally.
This happened in Toronto. Check it out. Friday night, the batter fouls it down the third base line. The ball bounces in the stands, and check out this guy, hands full of refreshments. You gotta be kidding me. The ball lands right between his legs. He didn't spill a thing, and I don't think he's a tenor at this point. I still think, look at that, unbelievable.
And he's happy. I mean, that's really called being at the right place at the right time, right? And keeping your wits about you when it matters most.
That could have ended very differently.
I'm impressed.
Yeah, that was pretty good.
I'm impressed.
I am too.
Mr. Phillips would be that impressed if you can do that and pass the EOC. Problem number 6.
All right, in this problem, we're going to look at Joe and his studying habits. Joe is an algebra student and wonders how the number of hours he studies for a test is related to his test grade. He graphs the number of hours studied for each algebra test on the x-axis and his grade on the test on the y-axis. The line of best fit includes the point 1, 60 and 4.5, 95. All right. Which of the following statements is true based on this data? Now I'm just going to read through this problem to see if I can figure out what they're asking for, and then go back and look at the important information. A. For every hour of studying, his test grade went up an average of 5 points. B. For every 5 hours of studying, his test grade went up an average of 1 point. C. For every hour of studying, his test grade went up an average of 10 points. Or D. For every 10 hours of studying, his grade went up an average of 1 point. So basically, it sounds like they're trying to figure out the relationship, just like he said up here, between the number of hours he studies and the grade, the points he gets on the test, right? The increase he gets on his test. That sounds like a slope problem because it shows the relationship between two things, right? So basically, they're giving us these 2 points and they're saying, hey, find the slope and tell me what that slope means. So slope is easy, right? Remember, slope formula on your reference sheet? This is x1, y1, x2, y2. All right, slope, and I'm going to do my math down here so we have more room to work with. Slope is equal to y2 minus y1 over x2 minus x1. Remember, my y2 was 95 minus y1, which is 60, all over x2, which was 4.5, minus x1, which is 1. All right, I have 95 minus 60, which is 35, over 4.5 minus 1, which is 3.5. All right, if you're not sure how to do that, remember, we have our handy-dandy calculator. You do get a calculator on your EOC. Yay. It looks very similar to this one. So I'm going to do 35 divided by 3.5 to give me 10. So my slope is 10. All right, so our slope is 10, and if you want to change this into fraction because it's a slope, it'll be 10 over 1. So what this means is 10 and 1 have to be involved somehow in this problem. So let's see if we could work smarter, not harder. What can we get rid of already? I'm looking for the numbers 10 and 1. For every hour, so that's every 1 hour of studying. That's good. The 1 is there. His test grade went up an average of 5 points. Well, my slope does not have any 5 in it, so that can't be right. I'm going to take out A. For every 5 hours, nope. 5 is not in my slope, so I could take this out. For every 1 hour of studying, his test grade went up an average of 10, or for every 10 hours, it went up an average of 1 point. So it's either C or D. I got rid of A and B just because I was working smarter, not harder. Now I actually have to know what slope means, right? Remember, slope is rise over run, right? It's change in Y over change in X. And it tells you right here that numbers of hours is on the x-axis. So hours is x, and the grade is y. That's really important. We had to go back and read and see that. Hours is x, and grade is y. So y is grade. So that 10 has to do with grades. And x is hours. So that 1...
You can tell Mrs. Phillips minus 10 the next time you see her. Not for me, for her.
between C and D. For every 1 hour of studying, that sounds right, 1 in hours, his test grade went up an average of 10 points. This sounds like this is it. Let's look at D just to be sure. For every 10 hours, well, no, that's flipped, right? 10 was supposed to go grade because Y is the grade, right? X is the hour. So they flipped this one. The correct answer was C. The correct answer was C. All right. If you have any questions on this problem, ask it on the Algebra Nation